Hi, this is week 3 of Physico Chemical processes for wastewater treatment. This is week 3 online live session. I am Vaibhav Kabadwal, PhD scholar from IIT Madras. So let's start now. So this is week 3. This is the lecture outline for week 3. We will study about flow equalization and aeration. Some part of aeration we will study in week 4 also, and some part we will study today. So this is the question related to flow equalization. So it says that which of the following statement is false for flow equalization? Overcome the problems related to fluctuations in flow rate and pollution load. Overcome the problems related to fluctuations in flow rate and pollution load. Yeah, it reduces the fluctuations of flow and the concentration variations. So it is correct. Uh, Smooth functioning of secondary and tertiary treatment. Yeah, it is also correct. It reduces shock loading also. So all three are correct. So answer is none of these. Which of the following statement is false for flow equalization? It requires large area requirement. Yes, it requires area. May cause water problem. Yeah, it is said may cause, because sometimes when we don't do mixing or aeration, what happens? Aeration, if you don't do, the particles, suspended solids will settle and and anaerobic condition will prevail. So gases will evolve and it will cause odor problem. But when mixing and aeration is not done, located after most of the primary units such as screening and grit removal, but before primary sedimentation. Yeah, this is also correct. So answer is none of these. Now let's see the next question. What are the two types of flow equalization basin? There are two actually. One is inline, another one is offline. So in inline, what happens? Suppose it is screen, screen, then grid. Then we will provide flow equalization basin in the same in series, and then we will provide PST primary treatment and all like that. So what happens? This is in line with this flow diagram. This is inline flow equalization basin. But for offline, what happens? Screens provided, grids provided. Then what we will do? The flow, we will provide a tank away from this line. So the thing is that the water which is in excess will go into this flow equalization basin, and if the water is less in this flow in this from grid, if the water supply is less, then we will take out the water from this flow equalization basin. So generally this offline flow equalization basin is used when the quality of water is not fluctuating much. Quality of water is not fluctuating, but the quantity is fluctuating. quantity or flow is fluctuating. And yeah, and you can see also, so in the offline flow equalization basin, the size will be more and the size will be less, and in inline, the size requirement will be more because it will be used throughout the flow. And while the offline flow equalization basin will be used when the flow is either more than average or either less than average. So it is not used if let's take an example. For 24 hours, it will be used 24 hours total, but it will be used less than 24 hours. This flow equalization basin. So these are two types of flow equalization basin. They are used to reduce the fluctuations of flow and flow characteristics. So when in inline flow equalization basin is used, this is used when fluctuation in flow, when there is fluctuation in flow and flow characteristics. Flow characteristics. Or either we can write like quantity when there is fluctuation in quantity and quality. When offline flow equalization basin is used, offline we use when there is fluctuation in flow only. That we discussed earlier also, fluctuation in only flow. Or we can say discharge, or we can say quantity of water or wastewater. Which type of flow equalization basin requires more volume? So we studied the inline will be used inline will be used 24 hours. Let's take an example in a day, because for 24 hours the water will enter into the wastewater treatment plant, while offline it will be used for less than 24 hours, so this will require less volume. Another question is, mixing is done in flow equalization basin to prevent. Why? Why mixing is done? I told earlier also, it is done to prevent settling of the solids. So that's why we need to provide mixing to prevent settling and to prevent settling of solids. And this mixing can be done by aeration also. So can aeration unit be combined with flow equalization basin? Flow equalization unit? Yes, it can be combined. What to design in flow equalization basin? So what to design? Think. So we need to design the volume and dimensions, and there are further two things also, like mixing requirement and air requirement. These two also. These things we will see later. Air requirement we will see in aeration, and mixing. We know we provide mixing to prevent settling of solids. So we will understand how basin volume is decided. So determination of volume and dimensions of the flow characteristics. So we will study specifically how much volume is required. So this we are studying for inline inline flow equalization in basin. So how we'll do? We will take data of time with respect to flow. Cumulative flow and flow means supply. Cumulative, one is supply, one is demand. Here demand means average average flow. Uh, Average flow considered. Let me write it again. So in this, what will you do? One is supply. So what is happening here? This is flow equalization basin. So this is oh, inflow into the flow equalization basin. This is outflow. So outflow should be how much? Average daily. We are considering it as average flow. Supply. This is supply. This is uh, let's take it as a demand. Means that is actually not a demand, but in reservoir it is considered like that. So we will consider it as supply. The demand we are writing it as average flow, daily average flow. So this data we know we have designed the other units with respect to uh, our average flow. So time we will check. We have the data from we have the hourly data 0 to 1 hour, 1 to 2 hour, 2 to 3 hour like that. We have the supply. Supply is not in our hand, but it has some fluctuations. So we will have some data of supply. We will have this will be in our hand because we know we have what for what uh, discharge we have designed this flow equalization basin. So this will be x x x like that. So what we will do, we will find with time we will find cumulative supply and we will find cumulative average flow. So what we will do, we will keep on adding. Suppose it was A, it was B, it was C, it was D. So 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5. Likewise, we will have so many values. So many values. So it will be A plus B, A plus B plus C. Why these three variables? Why these three variables? Because that supply, that inflow will be varying. This is inflow, this is outflow. Or we can write them as cumulative inflow, cumulative outflow. Cumulative inflow and cumulative outflow. So it will be x, 2x, 3x. Likewise, it will be an x. And it will be A plus B plus C plus D to so on. It will be an x. So then we will plot between cumulative flow and time. So it will be for a day, means it will for 24 hours. So this cumulative outflow will be like this straight line, and cumulative inflow can be like this. So what we will do, we will find the tangents like this, like this. We'll find this maximum value parallel to y-axis. This will be, let's say, A. This will be, let's say, B. So total volume of equalization basin will be A plus B. Now, next question is next question is from aeration. So aeration is unit process, unit operation, both are none. So what are before understanding what is aeration, we need to understand what is unit process and what is unit operation. So unit processes, these processes are chemical and biological processes, while unit operations are physical. In unit operations, physical forces are involved. So aeration is a unit operation. In aeration, oxygen acts primarily as what? Electron acceptor, electron donor, both or none. So we'll understand it with an example. So let's see. This is iron. What happens in our groundwater? We have we to extract in villages we extract groundwater. So what happens in groundwater? There is a lot of iron and manganese. So when we extract groundwater, so the water will also have iron and manganese. Iron and manganese. So when it contacts with oxygen, it will it gets oxidized into FeOH3 and it will be precipitated and it will be a precipitate. So what happens when it comes in contact with oxygen? Oxygen acts as electron acceptor, while iron acts as electron donor. So the oxygen acts as electron acceptor. So A is correct. So likewise for iron, manganese, and VOCs and all and many elim- uh, for many elements and compounds, the oxygen acts as electron acceptor. Next question is factors affecting maximum solute transfer. So factors affecting solute transfer. So solute transfer we are talking about aeration. So suppose this is the water body. Suppose oxygen is there in the atmosphere. So oxygen is so in this water body the oxygen will transfer. So what are the factors which affects the solute transfer? So this size and shape of reactor, temperature, nature of water, salt water, drinking water, wastewater, and its composition and concentration. So size and shape will also affect. Suppose if the reactor has less surface area, it will have less solute transfer. If temperature is more, then it will affect the solute transfer because it will affect the maximum saturation concentration of, let's say, oxygen. If temperature is more, then DO saturation will reduce with temperature. With temperature, DO saturation will reduce. And if the water will contain salt, wastewater, then the solubility of the elements or compounds will reduce in that water or wastewater. So that's why it is affected by all three. Solute transfer is affected by all three. So hence the answer is all of the above. Rate of diffusion of solute across a uniform cross-section area depends on rate of diffusion of solute across a uniform cross-section area depends on molecular size, molecular shape, concentration gradient, all of the above. So diffusion of solute across a uniform cross-section area depends upon. So let's take the same example like oxygen is in atmosphere, the diffusion, it is diffusing into the water body. So what are the factors which affects? Let's take one more example of, let's say, CO2, H2S. So they have H2S. So they have different shapes. Let's take an example of CO2. Maybe it has a structure like, it can have a structure like this, and it has different size. It will have a different shape if we compare it with oxygen. So its size will affect the diffusion, its molecular shape will affect concentration gradient, means how much is the available concentration here and how much is the available concentration here will affect the transfer. Whether if the concentration is more here and concentration is less here, it will move from high concentration to low concentration. So all three things affect the diffusion of solute across a uniform cross-sectional area. Which pollutant cannot be removed from aeration? Dissolved gases can be removed, through aeration, correct? Like ammonia, ammonia can be removed, methane can be removed, chlorine can be removed. Dissolved metals like iron and manganese, yeah, they also can be removed. We studied. Inorganic suspended solids, they cannot be removed. Like if we take an example of clay, sand, they cannot be removed through aeration. Now, which wastewater treatment process is used to remove the dissolved gases? So, let's say, let's say H2S, hydrogen sulfide, and VOCs. They can be removed through aeration. Aeration is performed during aerobic biological treatment for providing. Aeration is performed during aerobic biological treatment for providing oxygen and mixing. Mixing is provided to homogenize the solution. Like if microbe is here and food is here, food is somewhere else, organic matter. So if you mix, they will come in contact with each other. So that's why we provide mixing and oxygen. Hi Suresh, can you
Hi,
hear
sir.
me?
Hi, sir.
Hi, hi, hi. Were you there in the last class also? Hello.
Hello.
Were you there in the last class?
Last class I didn't, sir.
Okay, no, no problem, no problem. Did you watch the week 2 lecture?
I attended for two lectures, sir.
Or what did you attend?
I attended two assignments. I am
Two?
currently working in this field, sir.
Nice, nice, nice.
Water treatment
Good, good, good.
as a senior executive. Sir, I want to ask you one question, sir.
Yeah, yeah, ask.
Uh, while handling ETP,
Hmm.
apart from this lecture, sir, I am asking.
Okay, okay, yeah, I can try. That is what I can say. No
Okay,
problem.
sir. My video is not coming. Sir, I handled BTP while handling. I got a problem with the sludge treatment.
Such treatment. Okay.
Yes, sir. During that sludge treatment,
Hmm.
uh, uh, due to the presence of nitrogen, I'm not sure, but nitrogen
Okay.
in the it contained in the sludge and it got floated on the top side and in
Okay.
sludge collection tank.
Okay.
After 1 or 2 days.
Nitrogen in which form?
I'm not sure, but from the research only, I got something due to nitrogen content in the which was trapped in the sludge.
Hmm.
It takes the above and make it float on the water.
So, okay, can you tell me again what is the thing? So, from which tank you have collected the sludge? SST, PST,
Tube settler, sir. Primary tube settler.
primary tube settler.
Yes, sir.
Okay, primary tube settler. So, you are telling that from the sludge, what happened?
From this, whatever the sludge I collected, sir.
Sludge you collected.
From there, after 2 days, the sludge float on the top layer. It was 10 kl tank.
It was?
Floated on the top layer. Bottom separated, water totally separated, sir.
Okay.
What I did is before 2 days, I mixed. polyelectrolyte to the sludge.
Okay.
The formation of flocks also formed, sir.
Uh,
Uh, Water also separated.
hmm.
After 2 days, what happened? That sludge floated on the top layer, and water separated at the bottom.
But sludge will be heavy. It will be separated at the bottom only.
After 2 days, it flowed to the top.
Okay. So
Uh,
was it a physical-chemical treatment or biological? Which wastewater did you use? And was it actually
it,
biological treatment or
it was biological treatment, MBBS, sir.
biological? Then the thing is
Mm.
that now this course is for physico-chemical processes.
Yes, yes. I before I told you, sir, it is apart from my
I,
practice. I
I,
want to ask you some doubt.
I'm getting so see, as per my knowledge, what I can say is, if see the sludge mostly it will be at the bottom only. If it has a specific gravity more than one, uh,
I researched some from web source, sir. I got to know that due to trap of nitrogen inside
nitrogen.
the sludge content,
Yeah, yeah, yeah. Actually,
due to trap of nitrogen, it floated.
yeah, actually, what happens now? Yeah, tell.
I used to remove that sludge instead of removing from filter press. I used to just remove that sludge, whatever it was floated. It used to remain 2 to 3 days.
Hmm.
I use it to remove from top itself.
Hmm.
Like that, I was done dewatering from for so many days.
Okay.
It was successful, but it was right way or wrong way? I want to know.
Exactly, I can't tell because I don't have much field experience. But what I can say, like, what happens now? This nitrogen will oxidize to first nitrate.
Yes, sir.
This is called nitrification.
Hmm.
Okay. And then what happens when nitrate is converted to nitrogen gas? This is called denitrification.
Yes, sir.
So if you
Yeah.
if you give it more time, then nitrogen, then this ammonia will be converted to ammonia gas. This nitrogen gas, and nitrogen gas, if it will form na, so it will take the solids with it, and it will so solids may float on the surface also because nitrogen gas will produce this nitrogen gas. If you keep it
So,
for more time, nitrogen gas will produce and it will take the solids on the surface. So maybe it can be it maybe it is the issue. I don't know, but so process is this can be the process.
now my point is, sir,
Yeah.
whatever that nitrogen tapped into the sludge,
Hmm.
if I am continually removing from top side means, is there any after removing that sludge, whatever the nitrogen will again uh, release into the environment?
Nitrogen, see, if you keep the sludge for long period, the nitrogen, that ammonia will be converted into nitrogen gas. So better if you can remove it early, you better remove it early, or you can consult with your that engineers in that plant.
Okay. Okay.
Okay. So are you taking this course? So because I am teaching the some questions. Uh,
I am taking, sir. Already I attended two assignments. I am going to attend third assignment.
okay. So I'm teaching the some some questions so you can learn simultaneously.
Okay, sir.
Okay. So you
Thank
can
you.
see the PPT, na? Like
Eh,
this.
yes, sir.
Okay, then it is fine. Let me check. Yeah, correct. So till now I have covered few PPTs. If you want to see the video, it will be in YouTube also, and this content I will share in the Google Drive. So you can share, you can see this, you can read this PPT from Google Drive also. So in this PPT, we will study aeration. So aeration is performed during aerobic biological treatment for providing oxygen and mixing. So mixing is done to have a good interaction, to have interaction between microorganism and organic matter. Because if microorganisms will interact with organic matter, then only organic matter will be consumed and it will be uh, oxidized and it will form biomass. and which will
Yes.
settle. Solubility of a gas in water can be calculated using, can you tell? Solubility of a gas in water can be calculated using
Don't know, sir. Clear.
Henry's law.
In this law.
Yeah. So solubility can be calculated with the help of Henry's law. Yeah. Have you watched the videos of Professor V.C. Srivastav in YouTube and all?
I
Hmm?
have covered up to the parameters only, sir.
Parameters only. Okay, yeah,
After
you can
that.
watch later also.
Okay, okay, sir.
The solubility of gases increases with increase in temperature. Is it correct or false?
It's true, 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 sir.
So it will decrease. If you increase the temperature, suppose this is water, oxygen is
Okay.
there. If you increase the temperature, the oxygen will reduce or increase in the water. Suppose it is a glass, it has oxygen inside it. So the oxygen level will decrease, I think.
If you increase the temperature,
Yeah, if we increase the temperature, if I keep
water jet will be evaporated. Okay.
if we burn it, if we keep a burner below this and we will heat, the oxygen will come out.
Come out,
So
okay.
oxygen concentration will reduce. So that's why oxygen, the solubility of gases increases with increase in temperature. So it is false. With temperature, it will decrease. Okay, na?
Okay, sir, okay, sir.
Now, what is Henry law? Henry law's
The most,
equation. Are you aware of the Henry law?
no, sir, I don't know.
Okay, I will tell. So what happens in Henry's law? Henry laws, Henry's law is like, suppose this is a system. It contains water and gas. So the partial pressure of a gas A is directly proportional to the mole fraction of that gas in water. So partial pressure of A in this gaseous phase is directly proportional to the mole fraction of that gas in the solution. So if we remove the this proportionality constant, if we remove the this proportionality sign, we will get H into XA. H is Henry's constant here.
Mole fraction will be directly proportional to the partial pressure of gas.
Yeah,
Okay.
yeah. Partial pressure is directly proportional to the mole fraction.
Okay.
And if we simplify this, we will get this equation. Just some unit conversions are there. Mole
Okay, okay.
fraction, if we that you can see in the video lectures also. If we expand the mole fraction and we can get this, the concentration of gas in milligram per liter will be partial pressure of A into molecular weight of A into 10 to the power 6 divided by H into 80. That's it. So,
Sir, that
yeah.
Henry's law, where it is applicable in water treatment, sir?
What?
This law, where is applicable in that water treatment?
Yeah, yeah. In water treatment, so yeah, it is applicable if you need to find the solubility. So
Solubility, okay.
solubility, yeah. So this concentration, so it will tell like this is look, we'll solve one question also, then we'll understand in a better way. Uh, where is the question? Okay, question will come. So what happens
Okay.
now? It will tell how much is the solubility of water. And when we aerate something, suppose in water, let's say we have some gas H2S. So
Okay.
if you want to remove the H2S, so how much maximum at what concentration we can remove the H2S? So based on the temperature and partial pressure of that gas, we can calculate, okay, if we aerate something, we can get concentration up to this limit. So we'll solve one more question here. According to Henry's law, the partial pressure of any compound in the air is The partial pressure of any compound in air is
Proportional to the mole fraction of that compound is
yeah
not
proportional to the mole
directly
fraction,
proportional.
directly proportional. So it's A. Answer is A. Now some deductions from Henry's constant. So Henry's constant was what? Pa is equals to H into
X.
XA. XA was the mole fraction. So what will H tell that we want to know? So I have written here. So this it depends on the type of gas. So the thing is that for oxygen, the concentration, suppose it is a lake. Let's take an example. There is a lake, and above that there is nitrogen, there is CO2, ammonia. There are many gases are present above the lake. The lake is flowing like this. So based on the H value, we can say the solubility of nitrogen is more or oxygen is more. Otherwise, how can we tell? So Henry's law states that means it also tells that and this Henry's constant tells that whether the gas is less soluble or more soluble. So the concentration is more when H value is less. Understood, na? Like see,
Okay.
if H value is more, then in this formula we can see if H value is more, then concentration will be less. If H value is less, then concentration will be more in the water. Understood, na?
Sir,
So
in practical, how
yeah,
to find H value, sir?
H value that we have to calculate through experiments only.
Okay.
Yeah, depends on the and this H value depends on the temperature also. Suppose if temperature is more, then solubility will be. If temperature is more, then our solubility will be less. And H value is directly proportional to our temperature also. So if more temperature, more more H value, and if less temperature, more H value. If less temperature, less H value. So it is like some conclusions from Henry's constant. Now you can see here there is a question in which some gases are written. So we are telling we are interested in finding which has more solubility. So which of the following arrangements is correct for the gases in the increasing order of their solubility? So,
Okay, okay.
which has more solubility out of these things? So we know that
H
if
values.
H value, yeah. So if H value is less, then solubility will be this
More.
plus, yeah, more. Like we saw here, na? The constant if H value is less, then
Inversely proportional now.
inversely proportional. So which one will be the answer? If partial pressure is same.
H value, okay. CO2, O2, H2, N2. B, sir.
B,
Hmm.
CO2, H2, O2, H2, N2. Actually, this H value, if H value is more, then solubility will be less or more. This is more, na?
So, more solubility will be less.
So it will be less, and this will have solubility more.
More.
So which one will be correct?
We arrange increasing order, sir.
Increasing order.
Increasing means so less to increase. So from N to
Then answer will be A, I think.
A. A, sir.
Correct. Which of the following statement are true for Henry's law? Partial pressure of gas is directly proportional to the mole fraction. This is correct.
Yes. And this
Henry's
part is
constant depends on temperature that we studied. Yeah. Yes. It depends
more
on
the value of H, more the solubility of gas.
More the value
Yes,
of
sir.
H, less the solubility of gas. Which one is correct?
C,
C or D?
uh, D correct, sir.
D correct. C wrong. So A, B, and D are correct. Which of the following chemicals compounds cannot be removed by aeration process? So these are volatile organic compound. Volatile organic compounds. So VOCs, these are called VOCs in short. So they can be removed through aeration. This is calcium carbonate. It is a precipitate. Calcium carbonate. We have heard like calcium carbonate will precipitate in our utensils in home. You can see that some white precipitate. Those who use
Like
hard water.
scaling.
Yeah. What? Those who use
Yes.
actually hard water, and if they boil that hard water in some utensils, they can see white precipitate on the walls of some utensils. So that is
So we
called
have to
calcium.
remove through physical treatment only.
Yeah, yeah,
Calcium carbonate.
yeah. We have to remove the physical, not physical, actually physico-chemical process.
Physical chemical.
Yeah, so we can, we can, that is another thing that we will study later, how to remove calcium carbonate. And
Calcium
actually,
carbonate means lime only, sir.
yeah, calcium carbonate lime is actually CaO or CaOH2.
Calcium hydroxide.
This is lime. This, these two are the forms of lime. Calcium carbonate is something else. Calcium carbonate is
Hardness only.
CaCO3.
Hardness. Okay.
Yeah.
You have to remove ion exchange.
Hardness can be removed through ion exchange also, precipitation also, and boiling also. That we will study further
Okay,
in
sir.
the week, maybe 4, 5 or later. So this ammonia is a gas. So what we will do, we'll supply oxygen, and it will add the ammonia will the
Nitrogen,
ammonia will
nitrogen.
come out like that simple process.
Yes. Hmm.
We'll supply oxygen and the ammonia will come out. And ammonia stripping, that is called ammonia stripping also. So we'll increase pH also. That we'll see it later.
Sir,
Yeah.
sir, yeah, what is the better way for removal of ammonia, sir? If there is high content of ammonia means
See,
what?
ammonia can be removed biologically also. That is called nitrification. So the thing is
And
that
stripping process is that more efficient, sir, than
which
biological treatment?
which process?
Stripping.
See, cost-wise, I don't know because I have not studied the economy at how much money or how much investment is being done. I can tell the processes like ammonia stripping. What we do, we will increase the pH and then we strip it. Means we will pass air and air will replace the ammonia and that ammonia will come out. That is one method. Okay, that is called stripping. Simply.
What solvent we will use for stripping? They like we have to increase pH means you have to add lye.
Yeah, you can increase pH up. That depends that you whether you want to use NaOH or some other like KOH. It depends on the cost also. But basically, what I studied that we need to increase pH. In industry, they may use any solvent which they can feel it is uh, cheap or whatever, or it is high efficient,
I
high efficient.
encountered I faced a problem with an ammonia.
Yeah.
That's why I'm asking.
Yeah, no problem, no problem. So one is stripping that I told, and the next one is actually nitrification. So in nitrification, what we do that I already told that ammonia is converted to nitrate,
Okay, okay,
uh,
sir.
and
Nitrification,
then
denitrification.
yeah, and then nitrate is denitrified to nitrogen gas. That's it. There are other methods also that you study in actually biological processes. So the answer of this question is calcium carbonate. Okay, because
Calcium
ammonia
carbonate.
can be removed through aeration also. Surface aerators are used when just think about this question. You can tell them.
Surface aerators. Okay, depth of water body. Depth of water body. Depth of water body is less.
Yeah, correct. And diffuse aerators are used when
Depth of water body is high.
Yeah, correct.
Then only it will be
Yeah,
active.
because we'll supply water from the bottom mostly
The
in
bubble get diffused
different.
with more.
Yeah, 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 like that.
Yes.
Like this we do. Uh, Calculate the solubility of CO2 in water at 20 degrees Celsius. So this is the application of Henry law, which we are talking about now. So partial pressure of CO2 is this much atmosphere, and H value is this. So we need to find the concentration. We calculate the solubility. So here solubility
Okay.
is we need to find the concentration in milligram per liter. So it is simple. All things are given. So temperature is given, partial pressure of CO2 is given, H value is given. So we can find the concentration of CO2. We can find the concentration of CO2 in water at 20 degrees Celsius. Simply. So it will be PA. PA will be how much?
3.13
3.13 into 10 to the
into
power
10 power
minus
minus
4
4.
into molecular weight of CO2 is how much? 12.
C12 or oxygen 8 into 2.
Oxygen 6 into 2. I think it will be 44 grams. So it will be 44 into 10 to the power 6 divided by H. H will be 0.163
0.16 10
10
power
to the power 4
14.
into 18. 18. Yeah. So if you will solve, we will get the concentration of CO2 in milligram per liter. Do you have the calculator? Let
And
me calculate it.
okay, sir.
Write the equation of the variation of solubility of gases with temperature. Write the equation of variation of solubility of gases with temperature.
The inversely proportional temperature.
No, solubility of gas. No, Ca with temperature I'm asking. Or no, it's that we know that temperature is inversely proportional to,
CA.
yeah. But if I need to calculate the same thing at 10 degrees Celsius, the previous question was at 20 degrees Celsius. But let's say if I need to find out the same thing at 10 degrees Celsius, how can we find out? This we can calculate through this equation. So that H value, that H we talked now, pH in Henry's law, sorry, PA is equals to H into XA. So this H will vary with temperature, and this H we have calculated through this 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 formula. Log base 10 H is equals to minus delta H by RT plus B. So this is an empirical equation. So delta H is heat of absorption in kilocalorie per kilomole. R is gas constant. This value is given. And B is dimensionless empirical constant. So if we need different temperature, now let's say this. So we need to calculate at 10 degrees Celsius. So we'll first convert it into Kelvin. So temperature 273 plus 10, we'll convert it into 283. Then we will put it here. R we know this value, delta H will be given to us, and B is B will be also given to us. So we can calculate H. So this H we will put in this equation. We can calculate the solubility. Simple only. Major mass transfer resistances encountered for the transfer of oxygen are, check this question.
With mass transfer resistance.
Okay, first I will uh, tell this, then you can understand.
Okay.
See what happens. This is let's assume this as the surface of a lake.
Okay. Okay.
This is
Okay.
a lake. Okay. So nearby this lake, this water surface, na, what we say there exists a gas film. So this is a gas phase. Above that it will be gas phase. Below this it will be liquid phase. So just above the surface there exists a gas film, and just below the surface this is called interface. Interface, why interface? Because it is between gas and liquid.
Yes.
This surface is called interface. So just above the interface there exists a gas film, and just below that there exists a liquid film. So if the concentration, let's say, so you are aware that in actually uh, in our biological
Eh,
processes, in our biological process, the microorganism will consume oxygen. So the
yes,
oxygen
sir.
oxygen level will be less if some degradation is going on. So the oxygen concentration in the atmosphere will be more. Okay. So the oxygen will enter through this film. One is gas film, one is liquid film. It will pass through first gas film, then it will pass through interface. Okay, then it will pass through liquid film. Okay. So this was the concentration of oxygen in the atmosphere. Let's take it as C naught, and it will reach up to C here. So the oxygen will pass through first gas film, then liquid film, gas film interface, and then liquid film, and then it will and then this oxygen will be utilized by the microorganism for biological degradation. So this thing, did you understand? Hello,
Sir.
this thing did you understand somewhat?
I understood, sir.
Okay, okay, fine.
I
So,
have
uh, yeah,
questions.
ask.
Sir, during the transfer, sir,
Hmm.
actually in atmosphere there are multiple of gases.
Yeah, it will be.
Oxygen percent will be 21% only.
Yeah, correct.
During the transfer, sir,
Hmm.
uh, oxygen transfers and remaining gases also nitrogen also will transfer, no, sir.
Yes, nitrogen will also transfer, but why nitrogen will transfer? If suppose no, nitrogen will also transfer, but there is a difference. See, aeration is through diffusion.
Here
So
in this gas liquid transfer, here in this case only this surface aeration this was
surface,
this concept related to surface aeration
surface
only, sir.
aeration. Yeah, yeah. So why oxygen is transferring and why nitrogen is not transferring is because of concentration gradient.
Okay.
So the thing is that like if the concentration is more here and the concentration is less here. So the oxygen will move from more concentration to less concentration.
Okay. Okay. Okay.
Okay. And but in
Hmm.
the case of nitrogen, nitrogen will be equal in both. Means there is an equilibrium between,
Equilibrium will maintain an
yeah.
equilibrium.
So that's why
Okay.
nitrogen will not transfer. So
Okay. Okay.
oxygen is transferring because oxygen is being consumed by the microorganism here. So there is some deficiency in the water. So that's why to fill the deficiency, the oxygen is coming from the atmosphere.
This case, that example is applicable for during diffuser for diffuser also.
Yeah, diffuser, yeah. What happens? Diffuser we are providing to increase the level of oxygen in the tank
There will
or
be a
what?
there will be a bubble which
Hmm.
transfer through the gas phase will be around the bubble surface.
Yeah,
It will.
yeah, kind of, we can say. So just read this question, you can solve this, I think.
Major mass transfer resistive control for the transfer of oxygen. Yes.
So the answer will be gas film resistance, I told, interfacial
A.
resistance. Yeah, gas
Liquid
film.
film distance between the interface and bulk liquid phase.
Interfacial resistance was also there, and liquid film resistance was also there.
All the above, sir.
Yeah, all the above. So all three are correct. So likewise, this thing will also happen. Suppose this is your anaerobic treatment, you can say. So methane is being generated. Okay. So methane concentration in this tank is, let's say, more. It is a okay. So it is a closed system. So it is a gas phase. It is liquid phase. Liquid phase. So methane is being generated. So methane is less. Methane is more in the bottom part. So the concentration gradient is there. Here the concentration is, let's say, 20 milligram per liter, and above it is very less, around 0. Let's say 15 milligram per liter. Just for example, I'm taking. So the it will move from higher concentration to lower concentration, or
Yes.
S2S, or S2S we can say. So it is going out into the atmosphere if we release it. Theory of aeration. So theory I told like what happens. This change in concentration is equals to Ki A Cs minus C. So this KLA will be equal to DL by YF, and A is equals to A by V. So what happens? It is derived from Fick's law of diffusion.
Fixed law of diffusion.
Diffusion. So what Fick's law of diffusion says? Same thing like mass transfer, rate of change of mass is equal to dl. This is actually our diffusivity constant into into area, interface area, into dou c by dou yf. So if we see this, if we plot concentration versus time, that versus distance. So in this case, what are we assuming? Now there is only one film. The film is only liquid film. This is only liquid film. Here it is gas. Here it is liquid. This is liquid film. The concentration will vary like this. This will be Cs and C. So first we use this equation, and if you solve it, we will get this equation, dC by dt. So the question we will solve based on this formula in the next class. So just for the sake, I have told you these equations. Now I will study what are the factors which affect the oxygen transfer rate. So basically, the aeration is required to supply the oxygen into the tank or any, let's say, in aeration tank, we need to supply oxygen. So what are the factors which affect
Temperature affects you.
temperature?
Okay,
First one is
change.
temperature. Temperature affects the DO gradient and it affects the bubble size of the air up to some extent, and it affects KLA value like we studied na here. This is KLA value. So let's talk about KLA value a little bit more. So KLA, it is a constant of these two terms, this KL and A. So it is called overall gas transfer coefficient. Overall gas transfer coefficient. So yeah, little bit more I will talk about this. So this KLA is inversely proportional to resistance and directly proportional to temperature. So if resistance is more, then KLA value will be less, and if temperature is more, then KLA value will be more. So it is like this. And its unit is time inverse. So KLA value is directly proportional to temperature.
Sir, how
Yeah.
to find KLA value, sir?
KLA
D,
value, yeah.
uh, D, D,
KLA, we have here two equations that I told. KLA is
DC by YF.
uh, dl by YF and A by V.
What is DL, sir?
dl is diffusivity constant. See what I will tell. Yeah,
How
yeah.
to find the diffusivity value?
KLA value, na. See what
Yes.
we'll do through experiments. I will tell little bit about that. This equation you know, na, like dc by dt KLA CS minus C. Through graph we will find out that equation KLA value. Insert dc by dt is equals to KLA CS minus C. So if we'll integrate this, na, dc by CS minus C is equals to KLA dt. So if we integrate this, it will be ln CS minus C K, KLA T. It will have some limits from it will have some limit, let's say C1 to C2, T1 to T0 to T. Let's take it as 0 to T. So ln CS minus C2 minus ln CS minus C1 equals to KLT. It will be ln CS minus C2 divided by CS minus C1 equals to KLAT. So like this is the equation. So this saturation concentration we have. Initial concentration we will take it 0. What we do now, we do the experiment. So first we will remove all the DO from the water. So C1 will be 0, CS will be let's say 9, and then we with time t is equals to 0, t is equals to 5, t is equals to 10, we open the aerator, we on the aerator and we check the DO value with time. So that will be C2. This value will be C2. And we are getting a, so we'll plot the graph. So this is y is equals to mx. So this value, this slope will give us KLA with time. This this should be KLA divided by 2.303. So this slope will give us KLA by 2.303 value. So we perform this experiment at different times and we plot this graph and the slope will give us KLA value. I think you understood a little bit about this thing. So this is through experiments we can find it out.
Yes, sir, I understood, but
Yeah.
it will be vary for different types of wastewater.
Yeah, correct, correct. For KLA value will vary for different types of wastewater, and there is a correction
If,
also for that.
as a, if you found out at the initial stage means, then we have, if we want KLA value means we have to do every time.
KLA, see, the thing is that KLA value will be given to you by the, suppose the thing is that if you go for buying an aerator, so they will tell like the KLA value is this for KLA value is this for tap water, for tap
Okay,
water at this much degree Celsius. Okay. They will tell you that KLA value for tap water is this at 20 degrees Celsius. So for your wastewater, what wastewater you are going to use, they will not tell. Uh, they don't know that which wastewater you are going to use. So based on the correction alpha and beta, you need to calculate that how much KLA value for your wastewater.
okay,
Understood,
okay,
na? Like
okay,
the water which I am using here, it can be distilled water or it can be tap water. So my KLA value will be for my wastewater, my water or wastewater. So for your, you just apply some correction, and based on that, you can find the KLA value for your wastewater.
okay,
Okay. So this is so the factors affecting oxygen transfer. So we were talking about how oxygen is getting transferred and what are the factors affecting. So oxygen is transferred because of the concentration gradient, and uh, the factors affecting the oxygen transfer is first was the temperature, and second one was dissolved oxygen. So like oxygen transfer we are talking about. Suppose already the oxygen is saturated here. Let's say algae is there. Algae is producing oxygen. So will the oxygen transfer occur from atmosphere?
sir.
Suppose the water has algae.
Algae, okay, okay,
Algae is already present, and algae produces oxygen.
okay,
They consume CO2 and they produce oxygen.
okay,
So
okay.
oxygen is already present in the water. So from atmosphere, the oxygen will not come.
Due to concentration
Yeah,
gradient.
because already oxygen is present, or it may go out also if more oxygen is getting produced. So so whether oxygen is present or not, that is also a factor which affect the oxygen transfer rate. The third one is characteristics of wastewater. So suppose your wastewater is like it has like what is the composition of wastewater we need to know, and what is the concentration of specific substances. Like there are some substances which will float on surface, like surface active pollutants. I'm talking about these things. So they will concentrate on the surface and change the surface tension and create resistance. So then
Hmm.
oxygen can't enter inside.
Yes,
Understood, na?
yes, sir, like oil.
Yeah, oil and hexane and all. There are many things which will prevent the oxygen transfer.
Hmm.
So the characteristics also affects the oxygen transfer rate.
Yes.
Fourth thing is aerator, which affects the oxygen transfer rate, because we have different types of aerator. One will be like we are just agitating it. One we are providing from the bottom pipeline, we are supplying air bubbles. So what is the type of aerator which we are using, that depends, that affects the oxygen transfer rate. Like immersion depth, size of the bubble. This is for diffuse aerators. And how much is the turbulence, liquid spray, this peripheral speed and all. So it depends on the type of aerator. And other things are what is the capacity of aerator and what is the size of bubble also.
Yes.
So less size of the bubble is preferred.
Yes.
Next is oxygen transfer rate is not affected by. Earlier we studied which is affected by. Tell.
It will be affected by temperature,
Correct. Not
not
affected.
oxygen, not by uh, color, sir.
Color. Correct. These all three will affect the oxygen transfer rate. What are the two categories of aerators?
Two
What?
categories of aerators. Diffuser type and rotating.
These are not category, these are actually characteristics. Two categories are water in air and air in water. So, okay, I will tell you, you will understand it very easily. So, water in air. So, what will we do? Let's take an example. You have seen any, what we
Like
spray?
spraying of
Yeah. Spraying of
mm.
water. So, water is sprayed like this.
That will also transfer oxygen. Okay.
Hmm.
Okay.
So, water is in air. Okay.
Mm.
And air in water means you know it very well. Diffuse
Bubbles.
bubbles.
Mm.
These are the two categories. Simple only. Give one example of waterfall type aeration. So waterfall type. Have you heard of cascade aerator?
I didn't sir. Like rotated drum aerator I had. Rotating drum.
Yeah.
Half that drum will be half submerged and it will be continuously rotated.
Yeah. So cascade aerator is like this, step by step. What happens? This. So the
Okay.
water will pass from this bottom pipeline. You will supply the pipe.
I see inside this one.
Yeah, correct. The water will
The
go
step by
from
step.
this pipe. So it will form a thin film like this. Okay. So oxygen will come. So it will come in contact with air. Okay, like this. So oxygen or air will come in contact and it will cause aeration to occur.
Yes.
Understood, na?
Yes. I will.
Cascade aerator is a type of tell this, think and tell.
Cascade aerator. Now you told me water and air.
A or B?
Yes, sir.
Correct. Now tell spray aerator is an example of
Spray aerator. Water and air.
water and air, na?
Hmm.
Correct. Tell pressure aerator is an example of
What
this.
will okay? It will inject pressure aerator means it will inject into the water, sir.
Yeah, it will inject air bubbles into the water.
Okay, then air in water.
Correct. Read this. Centrifugal aerator is an example of.
Centrifugal aerator means
I will.
rotatory part. It will be moving on the flow.
Yeah. Let's
Flow
take it. This is the top area I'm just making.
centrifugal aerator. Okay,
This is
it
from
will
top.
float on the surface.
Yeah. So these are the these are the blades. It will rotate. It will keep on rotate like this. And if you see it from side, It will have blades like this, so it will rotate. So the oxygen
Okay.
will come from top.
That will be water and air.
Yeah, yeah. Water in air, air in water. So it will cause high turbulence and swirling. Water in air.
Both it will be
Let me check. I have a doubt in that. Most probably, I think it. Let's.
water and air only, most probably.
So characteristic of a radiator.
It won't diffuse air into the water, sir.
Okay. Radiator
Due to the
sensitive radiator.
turbulence,
Air
due
in
to the
water.
air in water, sir.
Air in water. It is air in water. So what is happening? The air is coming from outside and it is going inside. So it is air in water. Because water is here only. Water is not contacting, not going out. The air is coming from outer
Then
atmosphere.
it will be submerged fully.
No, no. Actually, this will be provided when depth is less. I will
Okay.
make
Then
it. I will make a
what are
diagram.
those blades? Blades will be submerged fully.
Yeah, blades will be submerged fully, and that air from atmosphere will go inside, and then it is called air in
The
water.
blades will be somewhat parallel, 45 degrees.
Yeah, blades will be like blades design is also there in mechanical and all. Maybe they can design the blades also. It is like that. So it will be like this.
By the blades, it will suck the air from outside to inside.
Yeah, the blades will be like this, and it will rotate, and it will cause some turbulence, and air from atmosphere
Okay,
will go inside. So it will be air in water.
okay, okay.
Okay. Precautions before aeration in lakes. So if you are going to aerate the lake, this is the lake. What precautions will you take?
We have
Because
to remove foreign matter first.
lake has its own ecosystem. Na? Foreign matter, that is another thing. Like this is suppose some floating materials are there that we will remove.
That only. Yeah.
That's it. So our main concern is to use the laminar circulation. So what happens now? If you are in lake, there will be some sediments at the bottom.
Yes. Yeah.
So it has fishes. It will have some other aquatic species also. So these species should not be affected. So for that we will use laminar circulation. Means it will have Reynolds number less than whatever that value we know, and we need to ensure that these sediments should not resuspend.
It should not be disturbed.
Yeah,
Okay.
it should not resuspend. So
Okay.
if these will resuspend continuously, it will affect the life of the fish and other aquatic species in the lake. So this thing we need to take care. It is not like we will directly go and we will set up the all the aerators. And
Okay.
one more thing we do like this, we will calculate how, suppose one aerator we installed here, so how much area it can cover. And based on that, we can calculate the aerator requirements like this. In top also we can find out. When whole lake water is oxygenated, is called as, like in this example I showed now. If if like this uh, we will cover the whole lake. So if whole lake water is oxygenated, is called as, I will tell. It is called lake turnover. When whole lake is aerated, it is called lake turnover. lake turnover. Power requirement for water body to maintain a given turbulence level and mixing are dependent upon.
Power requirement for water body to maintain a given
Thing you can tell. It's easy only. Power requirement for water body to maintain given turbulence level and mixing.
I didn't understood the question clearly, sir.
Okay, I will tell. So it is telling, suppose you are installing an aerator in the actual aeration tank, you know, little
Yes,
bit.
sir. Yes,
So
sir.
in this aeration tank, you need to set up the aerators. Okay,
Okay.
for a particular turbulence level and mixing. So the power will be required. So for aerator, we need to supply the power.
Yes, yes, yes.
So how will you decide how much power will you provide for a particular aeration tank for a means you need to know what is the type of wastewater.
And requirement of oxygen.
Yeah, requirement of oxygen. Okay, so here I have written. So you need to understand concentration of settleable solids.
Okay.
So you should know how much settleable solids are there, how much is the concentration. So how much aeration we need to provide to ensure them to resuspend into the water.
Oh,
Okay, so I need to know how much is the concentration of settleable solids in the aeration tank. Let's take an example. What is the geometry of that tank or lagoon? Suppose here it is rectangular from top. It can be maybe if it is circular, then it can have a different thing.
yes, sir. Yes.
Okay, and type of aeration equipment used. Suppose equipment we are using here centrifugal, and if you use diffused spray, then it will have a different effect.
Yes, yes, yes.
Understood, na? So
Yes.
power requirement of water body uh,
Depends on these
depends
three:
on these two
concentration
things.
of soluble
Yeah,
salts, aeration,
aeration tank,
geometry, and type of aeration. Okay.
yeah, type of aeration equipment used.
Yes.
It is like that. So we have covered the today's PPT. If you have further any doubt, you can ask. Do you have any doubt which you didn't understand today?
No. Okay, sir.
It's fine, I think.
It's
Uh,
fine, sir.
okay. So we will,
Sir,
yeah, ask.
I have only one person attending the classes, sir.
Yeah, actually, this is a master level course, so very few people attend and they will watch it in YouTube maybe if they need.
Okay, okay.
Hmm.
This is my first class I am attending, sir.
First, okay, you are attending it for the first time.
Yeah.
Last
Hmm.
time, two, three people were there, and this time only you came. It's fine.
Sir,
Hmm.
you are from.
Uh, I am basically, I am doing PhD here from IIT Madras.
Okay.
Yeah. You are
PhD in water
P-
treatment, sir.
PhD in environmental engineering.
Okay.
You are okay. You have done civil engineering BTech or BTech in chemical engineering.
Chemical engineering, sir.
Okay, nice, nice, nice.
From past 8 years, I'm in wastewater treatment
Okay,
in
nice.
pharma industry.
Okay, okay, nice, nice, nice. Good, good.
I have only little bit of practical knowledge. Theoretical knowledge I didn't have.
Yeah, yeah. With time, it will. But if you study, you can gain. That's it.
Okay.
Okay, thank you for joining. So, uh, I'm closing the session for today. So
Okay, sir.
we will meet next week.
Okay, sir.
Okay.
Thank you.
Oh, thank you.
Thank you,
Thank
sir.
you.
Thank you.